Hey, someone's there. All right. So welcome everyone. We have activity 18 that's due next time. Gosh, I guess that's not due till Thursday, is it? Yeah, okay, we've got a little break here because we just got done with the exam. I'll take questions you have regarding really anything in the course at this point. I'm in the process of laying out a daily planner that we'll be able to look at for the next several weeks. I pretty well have everything done that I want to do, but I'll put a few finishing touches on it as far as quizzes and the homeworks when they're all due and when the next exam is. So that's what's coming up. Class, of course, comes up tomorrow, but I guess there's really nothing due until, okay, my labs are due before class tomorrow. I have figured out, I've had several students email me telling me how you can get the activities to load back in the assignments page. Evidently, you photo them, turn them either into a JPEG or a PDF file, email them to yourself or put them on the cloud storage someplace, and then from the home page or from the assignment page, put those where it says to upload a file. Include the file there. That way they're right where I need them to be. So I was told it was easy. I don't know. I have no experience looking at it year end. Anyway, so that seems to be the steps. You download it, or if you want to just work on I'd rather, if you have a printer access that you print it out, it makes creating a little easier. But if you don't, do the work on the sheet of paper. Show enough detail so that my graders can know that you know what you're doing. Photo them. Again, I think either a JPEG or PDF. There might be other formats that work as well. Send that then either to cloud storage or put it on your computer and upload it on the assignment page so my graders have something to do. Got brand new markers. They just came in this morning. I'm excited for that. I was told over the weekend that chances of being allowed on campus to retrieve more were pretty slim. So evidently they don't want anyone on any of the buildings if they can avoid it. So I'm waiting in the chat box, looking at the chat box, looking for some sort of question from any of you. So if you have a question, let me know. I'm going to, I forgot to print off a copy of that last activity. So I'm going to make double sure that I have access to it. Hopefully you can see me when I'm on this other screen. Let me know if that messes things up. This is the first time I've tried it after all. All right, let's see what we got here. The new home for activities, there it is. And it's open. So whatever questions you have, let me know. Oh, I'll mention a little bit about the exam. As I said in an email, it was done really, really well. I think the last person who planned on taking it finished it yesterday. So I should be able to release the results and let you have a look at it. When is activity 18 due? It is due start of class on Thursday. So we're going to sort of run this the way we've been running it. I'll put out the video, the video notes that you want to fill in. You bring those to class the next day, so you bring those to class on Tuesday. We'll work through them in class then on Tuesday. Hopefully, if you get a chance, certainly it's going to be beneficial to work them out a little bit ahead of time. And then we'll cover them in depth. Whatever questions you have over those, we can cover in depth either at 2:15 or 3:45. Feel free to join either group, and then they'll always be due at the start of the next class. Typically, a lot of groups would finish them during the class time and be able to turn them in that day, but they were never due until the start of the next class. So let's just keep on going with that. I think I was able to set a submission deadline, so that's another way you can look at the assignment. I'm going to look at mine right now and see if I did that. Activity 18. I think some of this I can look at just as you do, but boy, I had trouble. I tried to upload some stuff on the assignment submission. I couldn't do it either. Yeah, it's due. Yeah. So there's a due date and a due time. So if you are in the early class, it's due at 2:30, and if you're in the late class, it's due probably at 4 o'clock. It seemed that Blackboard liked to break things up into half-hour intervals instead of 15-minute intervals. So that's a long answer, Stefania, to your short question. It's due at the start of class, just like always. It's always due at the start of class, the next class period. There's a little bit of material that we've decided, the coordinator decided to cut. It's integration by substitution. It's probably one of the more difficult symbol manipulation things that we do. The concepts are easy enough, but it's easy to get lost in the weeds. And since it took us a couple of weeks to get back on our feet, she thought that would be a good idea to cut that out. So I will have to adjust some of my videos. Most of the videos that you've seen this semester have been pre-recorded in previous semesters. I think maybe I did 3 brand new ones this time. I might have to do a few more new ones coming up. Can we go over number 5 from the video guide? Sure, if I can remember what the video guide was. Hopefully I have it here. Oh, I do. Okay. Number 5 from the video guide. At the end of the video, try this one. All right. Hey, by the way, I'm on a different screen. Can you see what I'm doing as I'm on this screen? Type either a yes or no, someone, please. That way I'll know if I can keep doing this, because it's really handy for me not to have the paper in here. It's really handy just to work off of this this laptop. I appreciate being able to do that if I could. Oh, good. Excellent. So there's the problem. Let's see if we can piece through this part by part. The first thing I notice are the plus and minus rules that allows me to separate these and do them independently. So if I really take this one all the way apart, here's how I could see it. There's a 7 in the denominator, therefore there's a fraction of 1/7 as the constant multiplier. I could bring that 1/7 right up front if I wanted to, and rewrite this first one as the antiderivative of e to the x dx. So this whole thing just becomes that. Again, the 7's the divisor, so let's keep that 7 a divisor. Multiplying by 1/7 and dividing by 7 are the same thing. Okay, on to the next one. The 2 is the constant multiplier. Plus minus rule says to bring the minus down. 2. And again, I'm going to bring that out in front of the antiderivative sign. It doesn't matter if you do or if you don't. Let's rewrite this then as x to a power. That's x to the 1/3. Follow that up with the dx. Notice my copious uses of dx here. Anytime I have an antiderivative sign, I want to follow that up with a d, whatever variable I'm using. In this class, we're sticking with one variable. If you go on to calculus proper, you could have dy's and du's and dx's and x's and y's and u's all into one of these. But this is a little less complicated than that. Okay, carry the plus sign. So again, the first thing I noticed is a plus and a minus sign, which allows me to separate this apart. Now, this last one is one of those ones where you cannot use the power rule. If you try, it fails, and I'll show you why it fails in a second. But remember, we can rewrite x to the minus 1 as 1 over x dx. Okay, so and here I go through this. I want to come up with the antiderivative. So my question is, what function has the derivative of e to the x? And fortunately, that's just e to the x. So the derivative and the antiderivative and the function itself, man, that never changes. The second derivative of e to the x is e to the x, the third derivative, and so forth. So carry that on through. Here's the constant multiply rule. We're going to keep that. Now I use the the inverse power rule of what I did before. What I used to do is bring the power down and reduce the power by 1. Now I'm going to do the opposite steps in the opposite order. I'm going to raise the power by 1, and then instead of multiplying by that power, I'm going to multiply by the reciprocal of that power. So there's the second part. If you want to write that as 2 over 1, feel free. Manipulation of fractions should be old hat by now. And then finally, we need the function whose derivative is 1 over x, and that is the natural log. Again, I need the absolute values here just to make sure that the domains line up. This one I can plug any number in the world in here and come up with except for 0. Any positive or any negative, I can plug any positive or any negative in here. Without the absolute value signs, I wouldn't be able to do that in the bottom one. So I don't care if you memorize it, it doesn't really matter. Stick a plus C at the end. Now let's gather everything up and make it look as pretty as possible. And then I'm going to finish my work on this one, and it's really important to be able to do both derivatives and antiderivatives simultaneously. They are going to be on the final in about a month's time. So I'm going to simplify everything up. There's 1/7 e to the x minus 2, 4 cross cancel, minus 3/2 x to the 4/3 plus natural log absolute value of x plus c. So that looks to me like the antiderivative. And now I'm going to check my work by taking the derivative. And it's really important to be able to do both antiderivatives and derivatives. And it seems like it usually takes about a week, maybe close to 2 weeks for students to be able to shift their brain both forward and backward, forward and backward. And I find it's easier for students to do that if they practice going both forward and backwards. So here we go with the derivative. So here's my check part. I'm fairly sure this is right. Here's my check. What's the derivative of 1/7 e to the x? That's 1/7 e to the x minus. What's the derivative of this? 3/2. Bring down the power, keep the x, reduce the power by 1. What's the derivative of natural log x? 1 over x. When I simplify this, 1/7 e to the x, that cross cancels, that leaves a 2, minus 2x to the 1/3 plus 1 over x. Whoops. And hopefully that's where this problem started. So I'm going to go back to my activity video guide and see if that's where that started. Yep, x, e to the x over 7, good enough. Minus 2 cube root of x, yep. X to the minus 1, sure. So if I want to line this up exactly with how this problem started, I certainly could do that. E to the x over 7, sure enough. There's my cube root, minus 2 cube root of x, plus, and if I wanted to rewrite this as x to the minus 1, I could. Remember, that's what was inside that antiderivative sign at the start of that problem. So we've done it. And again, usually it takes, a couple weeks practice with these, and then it tends to go pretty smoothly. Okay. So there's our first look at an antiderivative formally in any of these classes or review sessions. What's the next question for anyone? Does this clear things up pretty well? We can work a few more similar. I could put a few on the board if you wanted me to do that, and you could practice just some of that symbol manipulation working from antiderivatives. Might be a good time to practice a bit if you'd like me to do that. Otherwise, whatever questions you have for me, I'm ready to answer. So, by the way, this should have been on your video guide. Oh, by the way, I've been working a lot more regularly with students on the Blackboard Collaborate Ultra, mostly from my basic algebra classes. But that's another really nice tool that we can share back and forth. I figured out how I can open it up so that you can share either your computer screen, so you get stuck on a MyLab math problem, or there's a whiteboard that we can share to help us communicate back and forth. There's video, there's audio, so that works really well. And if you get stuck on anything and you want to spend, half an hour with me someday, hey, it's I guess the replacement for my office hours that I can hold, as many people in that at once as whatever I have demand for. Any other questions? I don't have anything to do until 5, so don't feel like you're holding me. Although it is a gorgeous day, and I wouldn't mind stepping back outside for a little while. Sure. That'd be a good one. Oh, then I should probably put some roots and radicals back in too, because those have always been a little bit of a trouble spot. I'll write this one down here. As long as the glare isn't too bad, that's not too bad. So have it that one. See if you can make it flow smoothly, and if you can, tell me what you get for the answer, and then start on the second one as well. Take a little break, fill up with tea. Oh no. It's got delivered all those new markers. Now I set it down. I don't know what I did with it. That's weird. Okay, if I saw this one, I'd be tempted to go through these steps first, sort of get it in the mode where the antiderivative sort of flows easily. So 6/5 is a multiplier, bring it out front. Negative exponents are going to be necessary here. By the way, there is no quotient rule and there is no product rule for antiderivatives. Do the same thing with that. There's our constant that's out front. Follow that with a dx as well. And then the last one again, there's a number I know that's a multiplier. I'm going to bring it out front. Then what's left over is 1 over x. So now I have it in a form where I can just apply the power rule, at least on those two. If I try the power rule on this one, by the way, this is x to the -1. So if I do try the power rule on this one, if I add 1 to the power, that's easy enough. But if I multiply by the reciprocal, I get 1 over 0, and that's not a real number. So there is one case, and only one case, where the power rule doesn't work, where you have x to a power and the power rule doesn't work. That's that 1 over x thing. And hopefully you remember well enough from our derivatives that that's the derivative of natural log. So here we go, fighting our way through the end of it. There's 6/5, it's a constant multiplier. Keep the x, raise the power by 1, multiply by the reciprocal of -1, which is 1 over -1, or simply -1. Same thing with the next part. Minus sign is good, 4 is a constant multiplier. Keep the x, raise the power by 1, and multiply by the reciprocal of the new power. 4 times a quarter, of course, is 1. So really, that's just x to the 4th. And remember that the derivative of x to the 4th is, by the power rule, 4x cubed. So that one we can check pretty well by inspection. Or maybe you might have noticed it right there in the beginning. What function has a derivative of 4x cubed? That's the 4th. And the last one brings back in the logarithm, 8 natural log absolute value of x. And then you can add any constant after that you wish, because when you take the derivative of these 4 terms, the derivative of any constant, regardless of what it is, that vanishes. So now let's make this look really pretty in the end. -6/5, so I could rewrite this as -6 over 5x. I could rewrite this one, as I said just a moment ago, x to the 4th. In this one, there's not a whole lot of rewriting I could do. If I wanted to, I could chase back and make sure the derivative works Rewriting this as -6/5 x to the -1, bring the power down, makes this positive, reduce the power by 1, makes that be -2. Sure enough, the derivative of this is this, the derivative of that is that, and the derivative of every constant is 0. So I've done it and I've checked my work. Now let's take a look at the bottom one. First step is to rewrite these and get them in a form where the derivative writing is easy. So again, I notice a plus sign here that allows me to write this as two separate antiderivatives and really compartmentalize my thinking. And we have 3/2 as the constant multiplier. Might as well place that 3/2 out front. Now we have to get x to the correct power here, and there are two things going on with this x. Number one, it's in the denominator, which makes the power be negative. And the second thing is it's in a radical form, so it has to be some sort of a fraction. Square root is the 1/2 power. So two things going on. Negative exponent because it's in the denominator, and 1/2 because it's a square root. Same thing on this one at the start. Bring the 7/5 right out in front. That way it's out of the way and we don't have to worry about it. Keep the x, rewrite it to the correct power. And notice I have a dx here and a dx here. It's the only appropriate way of writing it, I should say. So now let's go ahead and use the new power rule for antiderivatives. Constant multiplier, we leave a little space there because you're going to need it for a multiplier later on. Keep the x. Now the steps are the opposite. We raise the power by 1, 1/2 power, and we multiply out front by the reciprocal of that power, 2/1. That half is antiderivative is taken. We'll go back and simplify it in just a second. Keep the 7, keep the 5. Keep the x, raise the power by 1. That now becomes positive 3/2. Multiplied by the reciprocal of that new power, 2/3. Add on c. One more time, the steps that I'm doing with the antiderivative are the opposite of what I did when I did the derivative. The derivative, bring the power down, reduce the power by 1. Antiderivative, bring the power up, multiply by the reciprocal of the new power. So now let's make it look nice and pretty, simplify our fractions, get it back in root and radical form if we need to. 3/2, 2/1, those cancel. So 3 square roots of x plus, there's no cancellation there, 14, 15 square root of x cubed. And then as always, the plus c at the end. So there we have a couple more practice ones, and there'll be plenty of practice on the activity that's already loaded on Blackboard. Any other questions? You're welcome. I'll have to say, from my perspective, it was a little bit of a challenge to get all this up and going, but I was really impressed with the last exam, and I'm getting a lot of questions on these chats. I'm getting a lot of views, so overall, I think it's going better than I expected it to. I was bombarded with emails from the administration thinking, oh, the students are going to freak out, they're not going to be able to do this, they're going to hate it, they're going to drop out. I don't know, I was giving you a lot more credit than that. I really wasn't too worried about any of those things happening, but it made me worry for a little bit. I don't know. Anything else? How would you do some of the antiderivative e to the u? Oh, okay. Sure. Luckily, when I ordered my markers, I ordered them in a 6-pack with we fill a blank. 16 So let's say, first up, before we look at that one, let's look at one that might even make more sense. So if we have that problem, it's a 16 as a constant multiplier, 16 antiderivative e to the x dx. Okay, 16 is a constant multiplier, bring it along, and then think about, well, what function has a derivative of e to the x? E to the x does. So we're going to continue that as e to the x, and then plus c. So that problem doesn't really change if we change our variable. If I change this to a u, as long as I change this to a du, then everything will work exactly as it did before. The only exchange thing is my variable. Now this is a totally different problem. If I write it like this, then it's a Calc 1 problem. We treat e to the u as a constant because the x is your variable, but that's a totally different animal for a different class. And we will never have any in this class where those disagree, so you don't have to worry about throwing tricky little questions in there about two different variables. And we're only working one variable calculus in this class. So it doesn't really matter what that unknown is, as long as we're consistent with those two things, and we always will be consistent with those. You're welcome. Any more questions? All right, we'll sign off for today. If there's something else that comes up, send me an email. Again, we can chat on Ultra, or we can figure out how to answer those questions. Next thing is due on Thursday, and I look forward to communicating with all of you tomorrow during class. Oh, the next quiz, we won't have a quiz Tuesday because there's no new material to cover. So our first quiz will be at the tail end of class on Thursday. And the type of questions I'm going to ask on the quiz will be some of the basic antiderivatives, because that's what we're doing on tomorrow's activity. So remember, the quizzes are always what we did on the previous activity. Right? Talk to you soon.